Okay, here is your review for the Unit 1B assessment, which is your AP style test. So in part 1, and this really isn't going in your ISN, so it doesn't need a page. So to determine the input values for each function that result in an output value of 0. So there were lots of questions on this one about what are you actually finding? Well, what are your input values normally? Those are x's. What are your output values? Those are your y's. So what are the x values that give you a y value of 0? So you need to set this equal to 0. So basically it is asking you for the zeros of the function. You have to understand what the different wordings mean and make it make sense. Okay, so we're going to start by factoring. So this would give me x plus 5 times x plus 5, which is x plus 5 squared. And then x plus 5 times x minus 2. So then when I reduce, these cancel out, which means I have a whole at x equals negative 5. This gives me a vertical asymptote. Well, I'm not actually canceling that out. I shouldn't do it that way. But this gives me a vertical asymptote, not a 0. That's what I'm looking for. This is where my 0 would come from, except that I already have a hole. Oh, that should be negative 5, goodness. But I already have a hole there, so that doesn't work. So there are no zeros. Or none, however you want to say it. All right, on this next one, I'm going to factor. I'm going to get x plus 10 times x minus 1. All right, and then when I factor this one right here, I'm going to do it up here so I have more room. 5 times a negative 12 is a negative 60. So that's going to give me 5x squared plus 30x minus 2x minus 12. That's going to give me 5x times x plus 6 minus 2 times x plus 6. So when I completely factor that, I'm going to get a 5x minus 2 and x plus 6. Okay, so since I can't cancel anything out, remember these give me vertical asymptotes, not zeros. These are where I get my zeros from. So x equals negative 10 and 1. All right, on C, when I factor, the numerator is a difference of squares, so this is x plus 8 times x minus 8. The denominator is going to be x minus 8 times x plus 4. So these cancel out. That means I have a whole at x equals 8. This is left. That would be negative 8. So my 0 is x equals negative 8. All right. So somebody asked me about how to label things because I think that they had like Z for zeros because that's how we had done it on some things. And is this okay? Absolutely. I didn't put that on here or here because that was all I had and I was basically just answering the question. Now here, I put, when I said I had a whole, that absolutely would need to be labeled so it didn't look like it was part of my answer. That makes any sense. Like if you're going to write down extra stuff for yourself, which is not a bad idea, and you're going to label it as one thing, make sure your answer is actually labeled so it's obvious what you're trying to do there. All right, so then this says determine the equation of each vertical asymptote. So once again, I need to factor. Numerator is difference of squares, x plus 2 times x minus 2. Denominator would be x minus 2, x minus 5. So then I would cancel these out, which gives me a 0 there. Vertical asymptote comes from the denominator, and so I have one at x equals 5. That is the equation. You cannot just put 5. All right. On B, it's already all factored for me. That's nice. So I can cancel this out with one of these, and I can cancel this out with one of these. All right, so what's happening here? Remember that the order in which things win the game, I guess, is vertical asymptote, whole, and 0, like this. So when I look at my x equals -1, or I'm sorry, x equals 1, x minus 1, I canceled these out. So I cancel this out, that gives me a whole at 1, but since I have something left in the numerator, looks like I have a 0 at 1, but the whole would win over that. So I actually have a whole at x equals 1, but that's not what this question is asking. Then when I cancel these out, looks like I have a whole at x equals -3, but then I have this left, which makes it look like a vertical asymptote at -3. Can't have them at the same time, so vertical asymptote wins, and you have 1 at x equals -3. Alrighty, then we need to factor here. So in the numerator, I would have x plus 9 and x minus 1. In the denominator, I can factor out a 2x. That leaves me with x minus 9. And so I don't have anything to cancel out here. And I'm looking for my vertical asymptotes. So I have 2 down here at x equals 9 and at x equals 0. And these are written separately here because those are equations of lines, where here they are zeros, so I can make a list of them. All right, so now it asks for coordinate points for the holes. Coordinate points meaning like an x, y type of situation here. So we're going to start out by factoring. In the numerator, I can factor out an x squared. That leaves me with 4 minus x squared. In the denominator, it's going to give me x plus 5 times x minus 2. Then I can factor the numerator some more. So this gives me x squared. And then that is a difference of squares. So this is 2 plus x and 2 minus x. All over x plus 5 times x minus 2. And I need more room than I have here. Because I can, in the numerator, factor out, let's see, I guess I'll write it right here. I can factor out a -1 right there, so that would give me negative x squared plus 2, not plus, times 2 plus x times x minus 2. So for those of y'all that just canceled those out and didn't worry about anything else, that could be a problem for you. And then down here I have x plus 5 times x minus 2. Okay, now they match, and now I can cancel them out. And when I do that, I'm going to erase this so I have more room up here. Now when I do that, I know that my x value is at 2. I have a whole at 2 something. And then I'm going to substitute my 2 into this reduced version here. So this is negative 2 squared times 2 plus 2 over 2 plus 5. So 2 squared is 4, times 4 is 16. You make that negative, so that is negative 16 over 7. Okay. And here I've got a factor. So it's going to be x plus 6 times x minus 2. This is going to be x minus 2 times x minus 2, which we could rewrite as x minus 2 squared, but at the same time, I don't have a lot of room, so I'm not going to. I can cancel those out. Looks like I have a whole at x equals 2, but, so if I wanted to say a whole at x equals 2, But then look, I also have a vertical asymptote at x equals 2. Which one wins? The vertical asymptote. So I actually don't have that, and it is no holes. All right, let's factor C here. It's going to give me x minus 1 times x minus 7 over x times x minus 1. So these cancel out. That gives me a hole. That's what I'm looking for here, holes. So I have a hole at x equals 1. And then I'm going to substitute the 1 into the 1 into the reduced version. So 1 minus 7 over 1, which is a negative 6. So my hole is at 1, negative 6. Alrighty, I've got to write their right and left limit statements for the following functions as x approaches negative 1. So the first thing I need to do is factor. So I get x plus 1 times x minus 1 over x plus 4. Nope, not x plus 4. X minus 4 times x plus 1. All right, so these cancel out, which means it's going to give me a hole at x equals negative 1. And because of what it says about the limit statements here, I know that I need to start off by saying the limit as x approaches negative 1 from the left of f of x equals, and the limit as x approaches negative 1 from the right of f of x equals. All right, so since I'm approaching a hole, this is where a hole right here. I am not doing a sign chart. Sign chart does not make sense here. If I'm approaching a hole, whatever my function looks like, there's a hole here, then these could both be positive on either side or both be negative. So the sign chart doesn't help me. I know what the x value is that I'm approaching. I need to know what the y value is. So when you're approaching a hole, your answers cannot be positive and negative infinity. Instead, I substitute the negative 1 into the reduced version, negative 1 minus 1 over negative 1 minus 4. That gives me negative 2 over negative 5, which is a positive 2/5. So my answers here then are 2/5 and 2/5, and they will be the same. All right. So then here, as I reduce these, well, that's it. I got a hole there at x equals 1. So hole at x equals 1. Looks like I have a hole at negative 1. However, this also says I have a vertical asymptote at x equals negative 1. So that wins out. Since I have a vertical asymptote, I need to know, am I going positive or negative, or like what's happening there? So this one is where I would have a sign chart. So let me go ahead and start with saying the limit as x approaches negative 1 from the left of g of x, and the limit as x approaches negative 1 from the right of g of x. And these answers will be, let me erase that so I have room. These answers will be positive or negative infinity. Because that's where I'm either heading to positive or negative infinity on either side of an asymptote. When I make my sign chart, I definitely need to put my negative 1 on there. You should also put any other zeros or asymptotes you have on there. I don't have any other ones, so just gonna leave that, but I would put it there just to have my parameters if necessary. So using my reduced version, which would be negative 1 over x plus 1, numerator is negative no matter what. Denominator, let's say we put in a -2, so that would be -2 plus 1, that would still be negative, so that is positive overall. And then if I put in 0, it would be negative over positive, which is negative overall. So as x approaches -1 from the left, remember we think about this being an asymptote here, -1 from the left, I'm going to positive infinity, -1 from the right, I'm going to negative infinity. And that's what that would look like. All right, so now we're solving inequalities, which means we are doing a sign chart. I factor if I can, can't factor, so there's nothing to factor. So I'm going to set up my sign chart here, and I put in all of my zeros and all of my asymptotes. I don't have any zeros, and the only asymptote I have here is at -1. And then I think about my open and closed circles here. Asymptotes, always open circle, no matter what. Zeros would be based on this, but I don't even have a zero, so it doesn't even matter. And then so this is just a little asymptote here. If I substitute, no matter what I substitute in, I have to take this sign in the numerator into consideration. So there's a negative up there. Substitute in a -2, this would be negative, which is positive overall. Numerator is negative. If I substitute in 0, denominator is positive. Makes that, that's not making it 0. Makes that negative overall. And I want it to be less than 0, which means I want it to be negative. So my answer is from -1 to infinity. And they are both open. All right, so make another sign chart here. I've got a -3 on here and a +5. Think about my open and closed circles here. Well, my asymptotes are always open. Because of this, my 0 is open. Then I substitute in numbers. If I substitute in a -4, that would give me a negative over a negative, which is a positive. Between -3 and 5 is going to be 0, so this would be positive over negative, which is negative overall. And then something after 5, like 6, would be positive, positive, positive overall. Okay, and these do alternate, negative, positive, negative, positive, negative, positive, as long as I don't have any tangency or togetherness. Then my answer here, since I want it to be greater than 0, I want it to be positive, so I'm looking for this and this. I'm going from negative infinity to -3. Open, because I already made that decision. And then 5 to infinity. And that's it. All right. Make my sign chart here. And I also need to factor the denominator. So I can factor that into x times x minus 1. And there's nothing to cancel out or anything. So I need to I have 4 things to put on there. 2 zeros, 2 asymptotes. 1, 2, 3, 4. And actually, I'm going to make that a little bit bigger. I'll spread them out a little bit better. And 1, 2, 3, 4. And see, I have a -2, 0, 1, and 3. My asymptotes, which are at 0 and 1, are open. The zeros, because of this, are closed. All right, now, although I have 4 things that I'm substituting into, I do have to take this negative into account. So basically, I'm going to start with a negative on every single one of them. And then I'll start substituting things in. So I'm substituting a -3. No matter what I put in here, I'm squaring it, so that's positive no matter what. And then -3 plus 2 would be negative. And then this would be negative, negative. So when I take all those signs into account, that would be positive overall. Another way to do it is to just ignore this negative, do your sign chart like you normally would, and then go through and change all the signs. Whatever works for you is fine. All right, so the -1, I already have that negative. This is the second thing's going to be positive, so do that for all of them. Those all have to be the same. This is going to be positive no matter what. -1 in here makes this positive, and then negative. So that is going to be negative overall. Between 0 and 1, do something like 1/2. Already took care of those two. Then this will be positive. This will be positive. This will be negative. It's positive overall. Between 1 and 3, I can do a 2. So I've taken care of those two. Then this is positive, positive. That's a negative overall. And then over here, I could do a 4. Taking care of those two, then that is positive. That's negative overall. So I want it to be less than or equal to 0. So I am looking for the negatives, which are right here and right here. So I'm going from -2 to 0. I'm including the -2, not the zeros, because I already did my hole in there. And then here, I'm going from 1 to infinity. I don't have to split these up because this is an open, I'm sorry, because that's a closed circle. If that was an open circle, I'd have to break it up. So this goes just going from 1 to infinity, not including 1, not including infinity. Okay. Then I have this one. I need to factor this one. So this is going to give me x plus 2 times x minus 2 over x minus 3 times x minus 3, which I can rewrite as x plus 2 times x minus 2 over x minus 3 squared. And since I have x minus 3 squared, that tells me the denominator is positive every single time. Here's my sign chart. 3 things on there. A -2, a +2, and a 3. All right. So my asymptote is right here. This is greater than or equal to, so these are both closed. So if I substitute in a -3, that's going to give me negative. The denominator is squared, so it's positive no matter what. It's positive overall. If I put in a 0, it's going to give me positive overall. Between 2 and 3, like 2.5, be positive. That's positive overall. And then if I do 4, that would be positive, which is positive overall. So again, see here that we alternated positive, negative. Here is where we didn't alternate, and we didn't alternate here because at x minus 3, we had some tangency and it was squared. Here we have positive, negative, positive, because at x minus 3 here, we had togetherness that was squared. So that's where you're not alternating. We want it to be greater than or equal to 0, so I'm looking for this and this. So my answers here, I'm going from -infinity to -2, and I include the -2 because it's a closed circle. Then here, I do not get to go from 2 to infinity because this is an open circle. So I'm going from 2 to 3. I include the 2, not the 3. And then I start back over at 3 and go to infinity. Okay. There you go. All right, so now we're going to determine the domain of the following rational functions. Remember, the domain is all real numbers except for anything that, any holes or vertical asymptotes, which means before you reduce, you can just look at everything that the denominator could be, and those are the things that your function cannot be. So x here, x cannot be, because our denominator can't be 0, -1, -9, or 4. So if I was going to write that out, I would go from -infinity to -9, and then -9 to -1, and then -1 to 0, then 0 to 4, oops, then 4 to infinity. Okay. All right, on B, I need to factor. Now again, since I'm just finding the domain, I really find it, just look at the denominator before I reduce. I don't necessarily have to factor the numerator, but let's talk about the fact that this is x plus 3 times x minus 3. And then in the denominator, that's x to the 4th, so I'd get x squared. And 36 would be 4 and 9, so minus 4, and then x squared minus 9. And then I can factor that some more and get x plus 3 times x minus 3 over x plus 2 times x minus 2 times x plus 3 times x minus 3. So just like on the other one, I have some stuff that I can, well, I guess the other one I had something I could cancel out, but I have lots of things I could cancel out here, but I'm finding the domain before that. So I can see here that x cannot be anything that makes the denominator 0. Can't be plus or minus 2, can't be plus or minus 3. So to write that out in interval notation, negative infinity to -3, -3 to -2, -2 to 2, 2 to 3, and then 3 to infinity. Alrighty, polynomial long division. I need to find f of x over g of x, which means I'm just straight up dividing. So negative x minus 3 dividing into negative x cubed minus x squared minus 18. Oops, but I have to put in here that I have a negative 0x, then minus 18. Got to use your, got to make sure you have your placeholders there. All right, so negative x cubed divided by negative x is going to be a positive x squared. It's going to be negative x cubed minus 3x squared. Then I have to go in and change the signs on the bottom row. Those 0 out. That should be x cubed. Those 0 out. So I get positive 2x squared minus 0x. So positive 2x squared divided by negative x is negative 2x. And then, so negative 2x times negative x is a positive 2x squared plus 6x. Those 0 out once I change my signs. And so then I'm going to have a negative 6x. I don't have enough room here. Negative 6x, so negative x, this will be a positive 6. And this will be minus 18. When I multiply that back, I'm going to get a negative 6x minus 18. And that my remainder is 0. So my answer is x squared minus 2x plus 6. There's my answer. All right, here I can't really write smaller. I'm going to try and write smaller. I'm going to divide x minus 2 into 4x cubed. I have to have a plus 0x squared minus 17x minus 3. And I can't just, stop on these like I was for slant asymptotes because I may not, or because this is just asking me to divide, basically. All right, so 4x cubed divided by x is 4x squared. Multiply that back, I get 4x cubed minus 8x squared. change the signs, those zero out. 8x squared minus 17x. So 8x squared divided by x is going to be a positive 8x. Multiply that back, I get 8x squared minus 16x. Change the signs. It's negative x minus 3. So it gives me a negative 1. And then I get a negative x plus 2. Change my signs, it gives me a negative 5. So my answer is 4x squared plus 8x minus 1 plus 5 over x minus 2. All right. Oh, plus a negative 5. Duh. Okay, number 8. Determine the left and right end behaviors of the following functions using the mathematical notation of a limit. So right here, even though you can't see it in my work here, left and right end behaviors of the following functions. That means that if we are talking about rationals, which we are right here, we're looking at horizontal or slant asymptotes, and even kind of gives it away right there what you need to look at. So I know I can start off with the limit as x approaches negative infinity of f of x, and the limit as x approaches infinity of f of x. All right, so then I need to look at my function, and I need to see if it's top heavy, bottom heavy, or tied in degree. And so this is my leading term in the numerator. This is my leading term in the denominator, which makes it bottom heavy. And when my function is bottom heavy, I have an asymptote, which is at y equals 0, which means the limit is 0 for each side there. When I look at b, I can write out limit as x approaches negative infinity of g of x, and limit as x approaches infinity of g of x. My leading term is here and here, because notice like over here that's not always in the front. So this time we are tied in degree. So since we are tied in degree, I have a horizontal asymptote. I take the ratio of the leading coefficients, which would be negative 1/4, is negative 1/4, and negative 1/4. All right, on C, let's see, leading term, and that means that we have, this is top heavy by 1, so I will have a horizontal asymptote. No, I will not. I will have a slant asymptote. Sorry, it just occurred to me that I didn't like answer these, so I was thinking horizontal. These obviously are both horizontal. This one is slant because it is top heavy by 1. And so I'm going to go ahead and try and put my work in here. 5x squared plus x plus 5. I'm going to divide that into 5x. Here, let me try that differently. I'll put it right here. 5x squared plus x plus 5. Divide that into 5x cubed plus 26x squared plus 11x plus 30. Okay, I think I can make that work. So 5x cubed divided by 5x squared is just x. So this gives me 5x cubed plus x squared plus 5x. Go in there and I change the signs on each term. Those zero out, so I get 25x squared plus 6x plus 30. And then 25x squared divided by 5x squared is going to be a plus 5. And then I don't have to do anything else because I don't care about the remainder here. So my equation is y equals x plus 5. So my left is going to be the limit as x approaches negative infinity of h of x, and the limit as x approaches infinity of h of x. All right, so y equals x plus 5. What I know about that line is it has a positive slope, looks like that. So as x approaches negative infinity, the function approaches negative infinity. And as the function approaches infinity, we approach infinity. All right. Then we have, okay, on D. Left, oops, I know it will be the limit as x approaches negative infinity of j of x. Right will be the limit as x approaches infinity of j of x. And I know that because those are end behavior limits. And so when I look at this and I look at my leading terms, it is top heavy by more than one. So it's neither one of these, but that doesn't mean I can't explain the end behavior, because if I divide these out, I get a negative 2x squared. And so I know that that's a parabola. It's negative, so it opens down. So the end behavior looks like that. So this is negative infinity and negative infinity. All right. When I look at E, leading term. So again, this is top heavy, but by more than one. When I divide those out, I get 3x cubed. So that is a positive leading coefficient, odd degree, so it looks like this. So the limit as x approaches infinity of k of, negative infinity of k of x equals negative infinity, and the limit as x approaches infinity of k of x would be infinity. All right, leading term here. This is my leading term. It is top heavy by 1, which means I have a slant asymptote. So this will be limit as x approaches negative infinity of m of x. The limit as x approaches infinity of m of x. Okay, so to divide here, that's going to give me negative 2x squared minus 3x minus 3. And divide that into 4x cubed plus 16x squared. Oh, of course, I'm going to run out of room. Okay, sorry. If I had done this on my iPad, I could actually write smaller. I can't write smaller on this board. Negative 2x squared minus 3x minus 3. Divide that into 4x cubed plus 16x squared plus 25x plus 10. Oh, sort of made it fit. All right, so 4x cubed divided by negative 2x squared is going to give me a negative 2x. Multiply that back, get 4x cubed plus 6x squared plus 6x. Change the signs. Go 0 out. That is 10x squared plus 19x plus 10. So then 10x squared divided by negative 2x squared is a negative 5. And that's all I got to do. That makes my equation. Y equals negative 2x minus 5. There's my equation. So that line has a negative slope. Looks like that. So as we approach negative infinity, y approaches infinity. And as x approaches infinity, m of x approaches negative infinity. All right, next one. Given this parent function above, we want to graph the following transformations. So here's what we know is happening. We're going to have a translation, left 2, and down 3. Okay? We don't have to actually write them out, or we would write them out differently, right? So I'm going to start with each point here. I'm going to start at -4 and -2. So I'm going to start with this point. I'm going to put my pencil there, but I can't really put it there because it'll make a point. But from there, I'm going to go to the left 2 and down 1, 2, 3. That's my new point. Do that for this point, which is at -2, 2. Start here, go to the left 2 and down 3. And then start here at 0, -2, go to the left 2 and down 3. And then this point, which really, since I'm not stretching anything, I can tell that that point should be right here, because it's relative to that one up there, and then here, that would be this one. And then from here, if I go to the right 2 and up 2, again, since there's no stretches, I can go to the right 2 and up 2 from there. And then from here, go to the right 2 and down 2. And that's what that looks like. I know I kind of missed them, but that happens on this board. So I got this, this, and then curve, and curve. And that's the best I can do. All right, so then here, I have, I'm going to reflect across the x-axis. So reflect across x. Then I'm going to go to the left 1 and up 2. So I'm starting once again at -4, -2. So start at -4, -2. Reflect across the x-axis, so I'm at -4, 2. Go left 1 and up 2, and end up right there. Then my next point I start at is at -2, 2. I start there, reflecting the x-axis down, move to the left 1 and up 2, and I end up right there. Then my next point, I start at 0, -2, reflecting the x-axis, left 1, up 2. And then, once again, I didn't stretch anything, so I can tell where these points go here. And that means I would go down and over, and over. And here's my curve, and curve. And remember, on the actual AP exam, you don't have to actually draw them, you just have to match them up. All right, so here we have a horizontal dilation by 1/2, because x is a liar, and then we also go down 2. Totally not the right way to write any of that, but I'm just doing it for myself, right, so I can figure out what's going on here. So I'm going to start at -4, -2. So since I have a horizontal dilation by 1/2, that -4 becomes -2, and then I go down 2, and I end up right there. And then my next point, I'd start at -2, 2. Horizontal dilation, I cut my x value in half, so that becomes -1. Then I go down 2, and I'm right there-ish. Okay, I'll try to do better. Oh, that's not that much better. And then my next point, I start at 0, -2. My horizontal dilation does nothing, and then I go down 2. And then I don't think I just want to place things anymore, because, like I did on the other ones, because I do have a dilation here. So my next point would actually start at 1, -3. So that horizontal dilation brings me to 1/2, and then I go down 2. And then I would start at 2, -2. 2, -2, so that becomes -1, and I go down 2. And then my next one is at 4, 0, so my horizontal dilation brings me to 2, and then I go down 2. And then I'm at 6, -2, my horizontal dilation brings me to 3, and then I go down 2. Right there. So when I sketch this in, it's like this, and this is a curve, and this is a curve. Like that, sort of, but better. All right, on this last one, I have a vertical dilation by 2, and I go up 4. So I'm starting at -4, -2. So my vertical dilation, my y value is at -2. I double that, I go to -4, and then I go up 4, so I end up here at 0, right there. My next point, I start at -2, 2 again. My vertical dilation, I double my y value, so it comes 4, and then I go up 4, so I end up here. My next one, I would start at 0, -2. Vertical dilation doubles that to -4, and then I go up 4. I'm right there. My next point is I start at 1, -3. Vertical dilation makes that -6, and then I go up 4. Then I start at 2, -2. Vertical dilation makes that -4. Go up 4 to 0. Then 4, 0. Vertical dilation goes nowhere. And then I go up 4. And then my last one, 6, -2. Vertical dilation makes that -4. And I go up 4. So it should look like this. So this is straight, straight, curve, curve, like so. All right, last page. Describe the transformations to the graph. Okay, so we're going to start at the left and go from left to right. So this negative means I'm going to have a reflection across x-axis. This 2 is on the outside of the function, so that is a vertical dilation by 2. Then I have this 1/4 that is inside that function, so that means I have a horizontal dilation by 4 because x is a liar. Then this is inside, so that means I have a horizontal translation of 1. It's a positive 1 because I'm going to the right. And then this is a vertical, oops, I did that twice. Vertical translation of 3. Positive 3 because we're going up. Okay, here I'm going to start with this 1/2. So that is a vertical dilation by 1/2. Then I have that negative. That is going to be reflection across. Now, since that is inside the function part, it's affecting x, so it's across the y-axis. Then I have the 3. That is a horizontal dilation by 1/3 because x is a liar. Then I have a horizontal translation of -2 because I'm going to the left, and then a vertical translation of -5 because I'm going down. All right, in the xy plane, the point -4, -6 is on the graph y equals f of x. Determine the new coordinate for the following functions. Okay, so let's think about what we're doing here. Everything that affects x, I got to change the sign on x, so my xy is being mapped to, and this is a vertical dilation by 1/2 because x is a liar, so that's -1/2 x. And then y is being multiplied by 5, and we subtract 2. So that means that negative 4, negative 6 would map to a positive 2 and negative 32. Then here, the only thing that's happening to x, xy is being mapped to x minus 7 because I'm going to the left, and then 1/3 y minus 2. So that means that negative 4, negative 6 is being mapped to negative 11, negative 4. Nope. Okay, it's actually a positive 4 because I totally ignored this guy right here. So this should be a negative 1/3, which would make that not a positive 4. Good Lord, let me just redo that. Okay, I ignored that. So now if I do the negative 1/3, that gives me 2 minus 2, that's actually 0. Yeah, there we go. You good? All right, number 12. Function values of polynomial functions f and g are shown above. Oh, I guess I scrolled too far. All zeros for each function are shown, and all zeros have multiplicity of 1. Okay, and all zeros are shown. H is f of x over g of x. Determine all x values of the wholes, vertical asymptotes, and zeros. Okay, so let's write out a little function then. H of x equals, so f of x, so I'm looking at this chart here. My zeros, what inputs give me an output of 0? My zeros are here and here. So that means I have an x plus 2, I have an x minus 4. Then here, I have zeros here, here, and here. They all have multiplicity of 1, which means I'm not putting an exponent on the factor. So this is x plus 6, x plus 2, and x minus 2. Okay, so if I can reduce, I can cancel these out. That means I have a whole at x equals negative 2. Vertical asymptotes, I have 2 of those. One at x equals negative 6, and one at x equals 2. And then this would be my 0 at x equals 4. Okay, so part 2 is the calculator. So wording on this one is very, very important. It says the function f has a rate of change modeled by the function g. So f has a rate of change modeled by g, and they give me g. Then it says describe when the function is concave up, concave down, increasing and decreasing. It is absolutely positively not asking me when this is concave up, concave down, increasing and decreasing. It's asking about f. But that's all I have, so I'm going to graph that. Let me go over here, and I'm going to graph the, I lost it on my paper, there we go, 4x cubed minus 16x. Sorry, I'm still a little slow on this, finding all the little, to cram all this on here, they had to put stuff in weird places. Okay, so there's my graph. Now here's what I need to know. I can zoom so I can kind of see. Obviously I'm not going to be able to see the whole thing, but that will work right there just fine. And so I'm going to write down my fun chart, okay? So I've got this, increasing, decreasing rate, increasing, decreasing, positive, negative. Okay, this is what they're asking about. This is what we can see. So when I want to decide when is this function concave up, I'm looking for the rate, which is what I graphed. When is that increasing? So I can come over here, and the function is increasing starting at negative infinity, right? This is all increasing until it gets to here, this point right here. Then it's decreasing, right, until it gets to here, and then it starts increasing again. And remember, we're talking about the y values increasing and decreasing, but we write about x. So the function that we can see is increasing, which means f that we're actually talking about is concave up from negative infinity to negative 1.154, and then again from 1.154 to infinity. All right, if I want concave down, that's when the rate of change is decreasing. This graph represents the rate of change. We're decreasing from here to here. Right, all this is decreasing. That means f is concave down from negative 1.154 to 1.154. Then the function is increasing. This is what I'm talking about, but what I'm looking at is the rate of change graph, so I'm looking to see when is that positive. So that function is positive from here to here, and from here to infinity. So positive from negative 2 to 0, and then from 2 to infinity. Negative 2 to 0, and then 2 to infinity. And then the function is decreasing when the rate is negative. So this function is negative here and here. So that means we are negative from negative infinity to negative 2, and then again from 0 to 2. All right, next one, last one. Time in seconds and height in feet. So a rocket shot off from a launcher. The table above represents the height of the rocket given in times, where t is at given time, where t is time in seconds, h is height in feet. And it says it right here, so that's good to know here. Complete the following. The data in the table can be modeled by this quadratic, and it tells me quadratic regression. Here we go. Write the equation of the quadratic regression function. Okay, so we're going to come back over here. I'm going to X that out, and then I'm going to type in my data, put in my table here. So I have 0.7, 1.3, 1.6, 2.2, 2.5, and 3.1. Then my y values, 111, 193, 233, 299, 324, 376. Okay, so there are my points I put in. If I hit this little magnifying glass, it'll make it a decent looking zoom level. I can do my regression. Remember, linear is the default, and it told me to use quadratic. So there is my quadratic regression. All right, here's what we have. Now, let me remind you that what you write down has to be correct to 3 decimal places. Hang on a second. Mine does not match the key. I wonder if I typed something in wrong. 193, 233, 299, 324, 376. Oh, I sure did. It's supposed to be 1.3. Ah, just didn't like my 3. There we go. Okay, didn't match what I did on paper. All right, so what I was starting to say was, remember that what you have to write down has to be correct to 3 decimal places. What they gave me right here, these are all to 3 decimal places, and that's fine. But remember, in case it's not, which we've already seen one where it wasn't, if I click this and I can export as custom regression, then it's going to give me more decimal places if there are. Like there wasn't for these two, but there is for this one, which doesn't matter, and it's not necessary. But I have this, so that's good enough. But remember, if it's not, that's how you get the rest of it there. So let's write this down. It basically just gave us our answer there. So we have y equals negative 15.873 x squared plus 170.476 x minus 0.6032. Okay, so I was just writing down what they gave me right here, which if you'd have put 0.6031, you would have been fine, or if you just put 0.603 would have been fine as well, because you'd be correct to 3 decimal places. Okay, so it says to predict the maximum height of the rocket. Well, that means I'm using my regression. So even though it zoomed that in for me, the maximum height, this is a quadratic, so it should be right about there. So if you just kind of tap right about where that is, it will give that to you. So the maximum height looks like it's about 457.125 feet. Predict the time it will take for the rocket to hit the ground. So that would be here, because if it's launched from the ground, here's the ground, right? So that time is 10.736 seconds. And then predict the height of the rocket after 7 seconds. Well, that I'm going to X this out just to get that kind of out of our way there. After 7 seconds, that is my X value, so I can put X equals 7. If I can find my equals button, X equals 7. And there's that. So that's that black line it just drew. So if I do that, it'll give me that intersection. So 7 seconds, it's about 414 feet. So that's 414.952 feet. And then it says predict how long it will take to reach 300 feet. Okay, so 7 seconds, that was an X value. 300 feet, that is a Y value. So when we come back over here, I'm going to type in Y equals 300. Y equals 300. And predict how long it will take the rocket to reach on it. And it says on its way down. On its way down. So this is the rocket on its way up, right? Hits the maximum height, then it's on its way down because it hits that twice, right? So it doesn't want both answers. It says on the way down, so that's why we're looking at the 8 number. And so my answer then is 8.516 seconds. And there you go.